Rathod sir,
Yes.
shall we start?
Yes.
Good evening, everyone. Once again, welcome back to day 8 of AICT sponsored 2-week online faculty development program on Foundation of Data Science. I take this privilege to warmly welcome Professor Abhijeet Salunke, Assistant Professor in Computer Engineering Department at S.P.I.T. Sir has 10 plus years of experience in teaching field. He is pursuing PhD in computer engineering from IIT Bombay. His research area includes network security, Internet of Things, cloud computing. He has published many papers in various international journals and conferences. I request Professor Abhijeet Salunke to take over and start the session.
Thank you, Harshil, for introducing me. Thank you, Rathod sir, for giving me this opportunity. I welcome all of you in this 2-hour session for using PySpark in Google Colab. Before I start anything, I hope all of you have received a particular document which you have sent or which you have uploaded yesterday on the video. If you guys have that with you can start the first assignment or first case study which we are going to do, that is Boston housing related case study that you guys can start with me. Second one, I suggest you guys stop and just see the demo, because second one will be a bit heavy on data side, so it might take more time for it to upload. But if your internal speed is very good and you think that you could handle both of them, so you can do that as well with me. But of course, you should be ready. So without wasting any time, let me just start with what just give me a second. I'm going to do. Just go. All right. Let me share my screen. So, I hope all of you are able to see my screen. Rathod sir,
It is visible. Yes, it is visible.
Yes, it's visible.
Yeah. Thank you. So if you have any doubts, any questions, you can put it into the chat. I'll be looking at the charts continuously. Let me begin with the first case study, that is Boston housing. The reason why I selected this case study is, I don't know a lot of what background you have done before this course, but since you are already through 7 or 8 days in this FDP, I hope somewhere around the corner you are already came across this particular case study of Boston housing. This is the very first case study that mostly people teach for the purpose of linear regression. So that's why I have taken this case study, so you will be able to relate this to PySpark. Before I start this case study,
Abhijeet sir. You can do anyway, some background noise I can hear. So you can close your video if you want.
Yeah. One second.
Yeah. Audio quality would be better than something like that.
Okay, sir. Okay.
Is it background noise?
Is it better now, sir?
Okay. But background noise is there still?
Is it there? Means if it's there, I can try something else. Is it there, sir?
You continue. Let us see what participants say after some time.
Let me check. What about now, sir? Is it okay now?
Better.
Yeah. So it's okay. I just took some action and now it's okay. So now let us do this first case study. Now, before we talk about this case study, let me talk about PySpark in general. You must have known by now that there are many libraries available for machine learning algorithms. There is sklearn, there is SNS, there is Matplotlib, there is Pandas, what else and whatnot. So why to learn PySpark specifically? You must have already done with Scala So why to learn PySpark specifically is PySpark provides it is inherently designed for scalable data analysis or scalable data science. It helps you to configure a Hadoop and your even SQL kind of things within that particular library. It is already embedded. What do you mean by this? Is see, for an example, when you run, if you are done with Hadoop somewhere down the line, you must know that there is something known as pick script where you can just write a program in pick script and how to put that on Hadoop, how to distribute it around the MapReduce program, all will be taken care by that pick script. Similarly, you have PySpark in your machine learning or data analysis ka domain, where PySpark is already written. You just write those scripts and run them. How to put them in Hadoop, how to use SQL. You can actually use SQL related functions using PySpark as well. I will show that as well. So a PySpark helps you in using your scalable data science or using Hadoop MapReduce system without worrying about how to put them over or how to distribute them over MapReduce. PySpark will take care of it for you, so you don't worry. So the second question which comes is, so should we use PySpark for everything or anything, or should we use PySpark for every case that we come across? See, PySpark is specifically there for scalable data. Scalable data means it will go on scaling. It will. You already know what a scalable data is. As I've seen your particular schedule, you guys are already done with the basics of scalability. So if you do something, if you try to use PySpark with a very small set of database, you already know that if you use a small data set with Hadoop or MapReduce system, it will give you a worse performance than running it linearly on a single core CPU. So please make sure that whenever you use a PySpark or whenever you use something related to scalable data science, you make sure that it is relevant to that field. It is actually a huge data. Now, the moment we talk about huge data, it is very, very huge. For an example, if you are using only CPU, 1 GB data might be a if you are using GPUs, it is general purpose processors, then maybe 4 GB data is a very big data. If you are using ASIC processors, then maybe 10 GB or 1 terabyte of data will be of huge. So it depends, huge data definition actually depends on what lies under it and what will be used to process it. So without any further ado, let us dive into this particular thing. Now, this is the first case study, but before the case study, let us first try to incorporate PySpark library in our Colab. Now, this is your standard Colab system, or this is what your standard Colab is. And this is my very first line of code or very first block of code. What I'm trying to do over here is, now remember, PySpark is not inherently there in your Colab. You cannot directly import it like pandas, scalar. You can just import them, but you cannot do same thing with PySpark. You first have to install those libraries. There are some installation which needs to be done. Once you are done with that, then and only you can use PySpark. The very first line is your apt-get install openjdk 8 dev null. Now, this one is a prerequisite for your Hadoop. This first line is a prerequisite. Now, if you see this apt-get install, this apt-get install is the same command which you use in Linux terminal to install something. So if you remove this first exclamation marks and run this command as it is in your Linux terminal, you will have this openjdk 8 headless installed into your system. The second one is to download this Hadoop system into your Colab. The third line will unzip that particular Hadoop 3.2. And the fourth line, of course, will install find Spark, that is your PySpark activity. The moment you install this, this will get incorporated automatically along with this find Spark. So you just run this thing and you will see that it will start working one by one. So if you have a good net speed, it will work very efficiently. So there you go. It is installing. It will take some time. If your net is slow, it will take some time. But if it is good, it will install within minutes or even seconds, as you can see. Now remember one more thing. Actually, there are version compatibility issues when it comes to Colab. Colab में कोई भी Hadoop उठाकर डाल दोगे तो नहीं चलेगा. Of course, and it has to be compatible with OpenJDK as well. So when you're installing, use these lines only. There might be some line which you will find, there might be some installation steps which you will find online, but please don't follow them. Irrespective of the script तुम लोग का same है कि नहीं. If you want to use PySpark, please use these 4 lines only. This is compatible with current Colab का whatever upgradation is there. Whatever is there available online right now, they are not getting installed because the Apache Hadoop version has been updated. So that's why they are not the persistent, or they are not working. They have become obsolete now. They will not work with Colab. So if you want to use PySpark, use these 4 lines as it is, and below code you can change as per your requirement, but this 4 line has to be there if you want to use PySpark or Spark for that reason. So let me go to the next line. Your OS. Now I hope you know OSs. Now whenever you doing something, now we have called or installed PySpark or FindSpark into our Colab. This is like setting the environment variable. I have called them. Now I want to make sure the environment of my particular Colab is set so that it will run. And this is what I am about to do. As you know, your Colab, each notebook will create a VM version, and that is why this thing, that is import os.environment home and spark home, I am trying to set an environment part of this instance of VM which is provided to me by Google. So I run this. It will not take more time. So these environment variables have said. It tells me that if I want to find you Java 8 OpenJDK, I will go to this library of Google Colab ka instance. And if I want to use Spark library, I will go to this instance of Google Colab directly. This one is where now I can import my PySpark. Now remember, if you don't do these 2 steps, this will fail. The reason is PySpark is not inherently there in Colab. Colab library, it is not already available. You have to make sure that you run these 2 steps in order to make sure that your third step actually run. This is where I'm importing PySpark, and this is where I am initializing it. You need to initialize PySpark. Now, I have taken FindSpark, I have installed I have initialized FindSpark. Now I am free to use PySpark functions or libraries or imports. The very first thing I'm calling is PySpark.sql import Spark session. As I said, with PySpark, your SQL will also fall into picture. You can use SQL related functions and commands using PySpark. Now, of course, the SQL will not be as equivalent as what you have been using. The thing is, there are functions written in PySpark using which you can run them on SQL command. There are SQL commands which are written in the background. You give those parameters to the function will take it to the SQL commands, and they will run those SQL commands on your data set, get a particular output and show it to you. So it is not like you will be able to write the SQL commands, but you will be able to query using SQL commands if you have this. And we want it, so that's why we are using this particular Spark. The third one, this particular next code block, you must have been very familiar with by now. This is where we are trying to import our data file. So run this, choose a file, and this is my Boston housing. I hope you guys have come across this case study at least once in a while. So being a very small file, it gets uploaded very quickly. So yeah. So this is bostonhousing.csv, green, variant, index, jazz, norms, rn. These are all the column names and midv. Now, if you guys have done, most of you have done it for finding out predictions of midv, that is median valuation of that house, and that's what we will be doing. Now, before I go into that, I am just running the ls command. Why ls command? To see which are the folders which I have. Now, I have previously incorporated Boston housing before this session, so that's why it is already present over there. That doesn't matter because I have Boston CSV over here. So I will just use this Boston CSV. The next block talks about importing features and regression. Now remember that. I hope you guys remember. I have already imported PySpark, that is PySpark I have initialized. And now I can import each and every function or each and every package from PySpark. From PySpark, from ML module, I want to take feature and import vector assembler. Now I hope you guys know what is feature previously, because that's what we do in ML. We take feature and we feature as something on which we train our data. So this is to vectorize, or when I want to process a feature, when I want to perform some analysis, or when I want to normalize data, I want to do some convert the feature, change the feature, I want to work on the feature, individual columns or individual features. I have this library known as features, which I'm importing as vector assembler. From PySpark ML regression, import linear regression. I am importing linear regression model, that is your machine learning algorithm linear regression. So I'll be using linear regression because most of the time Boston housing is used for that. So if I run this, okay. Before that, the last line talks about dataset is equal to spark read.csv, bostonhousing.csv, infer schema is equal to true, header is equal to true. What does this mean? Let me tell you. Previously, if you have used ML, you must have used pandas where you use pd.read.csv and then you put that CSV name and whatever truncated. But here we are using Spark, and that's why, as I said, this Spark is nothing but a variable of your SQL or your SQL session. So what I'm doing here is I am using this variable of Spark and I am reading CSV using PySpark library. I'm not using pandas to read this particular CSV. I want to infer schema from the CSV. That is, after taking the CSV, I want to know what are the headers of this CSV. That is, header is equal to 2. What are the header? What are the schemas means? Whether it is a double value, integer value, what kind of value it is holding. So when I do this, I'm actually creating a schema along with that CSV. Now let me run this dataset print schema. When I run this, I get that there is a particular header or there is a particular column or particular feature known as frame, and its data type is double, Zn whose data type is double, index whose data type is double. Now nullable is equal to true means it can hold a null value. So all of this, its data type and whether it can hold the null value is been written over here in this particular schema. This is the schema. This is what happens when you turn this infer schema. This is the information that you get into your dataset. Now here, what I'm trying to do is, I have called this vector assembler from my PySpark. Now, okay. Now I have taken a particular variable assembler to which I am assigning this vector assembler. Vector assembler means I want to create a vector. Which kind of vector? I want to have input columns as cream, Zn, index, cas, nox, whatever. All the columns except for my medv. Now what I did is I took all the columns which I want to create as input, and I also named a column which I want to call as attributes. I took this assembler as an object of vector assembler and transformed my entire data set. When I transformed it, I got this. I got all of these things: cream, Zn, index, cas, nox, Zn, age, div, rad, tags. Now remember, all of that was in CSV format. I got it in table format. That is, each in the column name and whatever is that column ka entries, I have got it into that format. I have also added this medv. Now remember, in this list, there is no medv. The reason why I'm not put medv over here, or the reason why I'm putting medv differently, is because I want to use this as my output column. These will be my input columns, whereas this will be my output. So what I did is, this is my output.show. When I show my output, when I transform it and I show my output, this is how it looks. But when I finalize data, that is output.set attributes and medv, this is what I get. So I have one vector where I have all the other attributes except for medv, and my output vector will be my medv. So this is all the other attributes barring medv, and this is my medv. Why? Because I want to predict the values of medv using these attributes. So that is what I'm trying to do. So this is my finalized data. Now I'm splitting this data. Now remember, I'm splitting this table. I'm not splitting this table. I'm done with this table. This was there. I have converted my CSV file into tabular format. From this tabular format, I have only selected these two columns. Now, this is attributes is my input column, which consists of all the attributes except for medv, and medv itself is my output column or output feature, which I'm supposed to predict using this attribute. Now I have my train data and test data, finalized data at random split 0.8, 0.2. That is for training, I'm using 80% of data, and for testing, I'm using 20% of data. I take this entire table of entries and I'm splitting it into training and test data. 80% will be training data and 20% will be test data. How will it be split? पहले 80% होगा नहीं, it will be randomly split. It will have a random split, that is, there will be, we are sure that there will be 20% of test data and 80% of training data, but you cannot say which row will be selected. It will be completely random. Then I have created an object of linear regression. Linear regression feature calls is equal to attributes, label calls is equal to medv. What does this mean is, I want to train a linear regression where features columns will be named as attributes and label columns will be named as medv. That is, this will be my attributes. I will take these attributes for training or training my data, and this is the output which I require. Using regressor, I do regressor.feed train data. This is something that you guys already know from. That is, I take regressor, this object, I feed the train data using this regressor, what is the object I have created, that is whatever with whatever attributes, it will get trained using these attributes and this data. After this regressor is been trained, I will evaluate it over the test data. Now remember, all of these functions, this fit, evaluate, are similar to your sklearn or any other testing data or any other machine learning algorithm which you find it in other libraries. There can be some differences, but mostly they are trying to do the same thing. This is where you fit it on the trained data, and this is where you are evaluating. That is your predictions. Now here you are trying to show that predictions, after doing the predictions on test data, what was expected, this is your test data. This is your test data attributes. This is the actual value which is there already present in the table, and this is your predicted value. So you predicted 23, whereas actual answer is 33. You predicted 42, where actual answer is 50. You predicted 27, where actual answer is 23. So of course, there are some errors. Of course, you will always have error in predictions. So this is your test data, input, output, and your prediction. This is actual input, this is actual output, and these are your predictions using linear regression of PySpark. Now I want to find out the errors which have happened into this data, or the errors which are occurring into it. So what I do is, first of all, I find out coefficients of my regression. Now I hope you guys know what coefficient and intercepts of regression are. So these are my coefficients of regression, and this is my intercept. This is where my regressing line or regressor line is intercepting, and these are the coefficients of that regression. These all of them. Now remember, it will change every time. The reason is because you are this. I'm talking about coefficient. They will change as your data split changes. This data split is completely random. So for each random data split, it will have a small different value, but that's it. That is what you already know about it. Now let us go to the next thing. As I said, there are errors into this prediction. I was expecting a value 33, but my prediction is giving me value 23. I was expecting a value 50, but my prediction is giving me value 52. I was expecting 23, and so on and so forth. So now I'm calculating my errors. Now I hope you guys know this, what is root mean square, what is mean square error, what is mean absolute error, and what is R2, or deterministic. So what I did is, from PySpark, I brought in evaluation, that is the regression evaluator. There is a particular library already present into PySpark, which you can directly calculate your RMSE, MSE, MAE, and R2 errors. This is my regressive evaluator. This is eval. where I am having a regressive evaluator called object whose label call is medv, prediction call is prediction, and metric name is RMSE. Now remember, label call means actual value is stored in medv. That is the value which is already present into the table. Now prediction call. This is nothing but the name of the column in which I have stored my predictions. So I am trying to compare this with this, that is medv with predictions. That is what I'm trying to say. I'm trying to find out the error between medv and prediction using metric RMSE, that is root mean square. Root mean square error, RMSE, is equal to eval.evaluate pred.prediction. So prediction is nothing but the name of this particular data instance. So I got this predictions and I printed this RMSE value. Same thing with MSE. MSE is equal to this first line is simple and just I am changing this eval.metric.name. Now remember, these two things will remain the same. I am just changing the metric name. I am not restating the eval entirely again. I'm just taking that same eval variable and I am just substituting or changing the value of eval.metric name. ये ऑब्जेक्ट जो क्रिएट हुआ है eval का, I am using it as it is. The only thing I am changing or substituting this is eval.metric name. Eval.metric name is MAE or MAC now, sorry, MAC now. And then I print this MAC value. Similarly over here, MAE, eval.evaluate, print.predictions, eval.metric name, MAE. That is mean absolute error. I'm just changing metric name by label calls and prediction calls is the same. And then I will print that. Then you have R2. Now in R2, I have eval.evaluate predictions. Eval, I'm changing this metric name to R2. When I do that, I will just get this R2 command. So when I run this, I will get my root mean square error, I will get my mean square error, I will get mean absolute error, and I will get my R2 coefficient using this regressor evaluator function or regressor evaluator library. Now, by looking at this formula, you must have understood that there are some functions in PySpark which are similar to other machine learning algorithms. For example, .fit. In other algorithms or sklearn, you have something as test or prediction. While in PySpark, you have evaluate. So only thing is the function names are a bit different. Otherwise, you can actually perform all of the functions which are there in other machine learning algorithms or other machine learning faculties or other machine learning facilities in PySpark. The only difference will be when you learn a machine learning algorithm, if it is way too large or it is larger for a particular Colab to run, it will make use of Hadoop underneath and it will run, it will distribute it using MapReduce and run it over. Now, in the beginning itself, I have told you that what is big is a particularly subjective question. What machine you are using, what hardware you are using, what configuration you have, depending on that, your definition of big or definition of large data set changes. So this is the thing. So that's why. So that's why I am.
Sorry to interrupt you.
Yeah.
But this is visible as a gray block. Is it same for everyone or might be a network issue at my side? But I'm just confirming.
What you are having? What, ma'am?
The screen is just visible as a gray block. Nothing is visible right now. Earlier the code was visible.
No, ma'am, there's some issue from your side, ma'am. It's visible clearly from our side.
Okay, so sorry to
yeah.
Yeah.
No, it's fine. It's fine. It's okay. Please make a note of these things. First of all, PySpark tries to run most of the things on the Hadoop itself. Whenever it gets the script, it will go on and try to run it on the Hadoop. So that's why I said when to use PySpark, when you should use PySpark only when you have a large data. So the next question comes. If I take a sklearn library and if I run it over there, and if I take a PySpark library and I run a particular data set using a machine learning algorithm with PySpark, so what will happen? Will I get a better result in PySpark as compared to sklearn? Depends. If your data is large enough to be run on the Hadoop, PySpark will give you better results. But of course, what is large? As I said, it is a very, very subjective thing. It is a very subjective thing to that particular what you are actually deployed or where you are actually running this code. So PySpark will always give you better result than sklearn or any other library which is not using scalable dataset is a false statement. It depends on what kind of data you are handling, what size of data you are handling, and actually on which hardware you are handling it. If you are having your own GPU, set of GPU where you are running it, of course, PySpark will give you a better, absolutely give you a better performance most of the time. Of course, your data has to be also that big to give you a better result. You know, it is running on MapReduce. It's trying to run your code on a MapReduce or whatever thing you're trying to do is on a MapReduce, and hence you will MapReduce, and hence, as you know, MapReduce gives you a better performance only when you have large data sets. So this is the first thing. I hope you guys are able to understand what actually is going on over here. Of course, there is not much to be much change from whatever you have learned in Python scripting. It is similar to your whatever Python you have using, whatever Python you have been using previously. The only thing is there are some syntax change which I have offered, but trust me, in the background there are things which are happening, and that is why we actually use such kind of libraries, because it makes our work very simple. It will take care of other things for you, that is how to put it on the SQL, how to run SQL commands in the background, how to run your Hadoop into the background. It will be taken care by PySpark, and that's what makes it beautiful. That's what makes it desirable. If there are any questions, please you can ask in the chat. Ask it into the chat.
Hello, sir. I have one question.
Yeah.
Sir, the processing, whatever we are doing using PySpark, is it distributed processing? Means is it distributed among multiple nodes and it is getting processed?
Yeah, ma'am. Actually, when you are using PySpark, the main component of it is you distribute it over the multiple nodes. If you have them, of course, in your PC, in Colab, they have many GPUs, so they do distribute it. But if you're your standalone PC, or if you're using your own, means you're using Jupyter Notebook, you have installed PySpark into it, so it will have only one CPU to run. So it will not be able to perform that better. But when you're using it on a very large network of GPUs like Google Colab, it is actually running distributed nodes.
In distributed environment.
Yeah, it will run on distributed environment.
And sir, one more thing, like regarding RDD, like do we have to use RDD for this parallelized or the distributed processing for Spark?
No. You don't have to use anything. It will be taken care by PySpark library, ma'am. You don't have to mention anything separately.
Okay, so RDD no need to create directly distributed.
Yeah. It is the PySpark library will take care of it for you. PySpark library, it is there.
Okay.
It will take care of underlying things where you distribute it on all this kind of thing will be taken care.
Okay, sir. Okay. Thank you, sir.
Anyone else? I think there are no more questions on this thing. So should I go to the next case study? Hello, am I audible?
Audible.
Yeah. Okay, let me go to the next case study. Okay, now this one is a very interesting case study. Before I start this, let me tell you something very important. This is one of the logs which are available by NASA. NASA actually have published these logs and they are available on their site. The thing with this thing is, just give me a minute. Sorry. The beautiful thing about this thing is it is actual working logs of NASA. The NASA have distributed their web logs or whatever their web server logs onto their site. They are around, there are from the year 95, if I'm not wrong. Year 95, July and August logs. They come around 163 and 206 MBs. Now remember, even this is not a huge data set, but still we have to use something, so we are using this. So log analysis is one of the best examples that you could have for a semi-structured data. When we talk about semi-structured data, there is nothing better than log. Secondly, I hope most of you have taught networks somewhere down the line, so you guys will enjoy this. Third and most important thing is it tells you about a very important point from PySpark. See, the moment we start using a particular library, we think that everything could be pulled off in that simple library. Now, as I said, when you use PySpark, PySpark tries to run everything using Hadoop. Because of that, your performance may degrade, because if your data is way too small, it will, and it is trying to run it using Hadoop, its performance will degrade. The best part about this particular case study is it uses mixture of many things. It uses PySpark. Whenever PySpark is not necessary, it tries to use pandas. Whenever pandas is not there, it is trying to use matplotlib. When matplot's graph are good, it is using trying to use SNS when SNS ka graph is needed, or SNS is equally gives you better representation. So this example will give you a complete understanding that when you are actually doing analysis, you cannot be dependent on a single library to do all the things, or you should not depend on that. That is what, when you talk about ML, that is what the beauty of ML. You have many libraries, so there must be some part which are better in one library as compared to others. Just because I'm here to deliver a lecture on PySpark, I will not say कि देखो PySpark कितना better है, PySpark से better कुछ नहीं. Last thing, before I enter into this particular discussion of this case study, what I expect you guys to know already, and what I think you might know already. The reason is, as you are down the course for 8 days, I consider that you guys have an idea of what regular expression is and or how regular expression is used. Because अगर वो पता नहीं है, तो it will be difficult for me to make you understand. I will try to give you a bit of an understanding, but I cannot go too deep into it because that is not the main subject. You will need regular expression because this is semi-structured data. The moment we say semi-structured data, you need to see, we cannot process anything on semi-structured data. We have to get it into structure. And to get it into structure, we use the regular expression. So if you have no clue about regular structure, it will be very, very difficult for me to make you understand. Sir, can you share the link of your Colab so it will be easy to use to copy it? Ma'am, I have already shared it. It will be over Moodle. On the Moodle where your course is there, it is I have showed IP in the file already, so you can just use it. You just upload it to your Colab and it will run. Just see into your Moodle account, log in into your Moodle account, and will do this. Okay. Now, before I go into this, please make sure that there are regular expressions. If you're not understanding regular expression, if you don't know anything about regular expression, don't panic. Only thing is, I will give you a bit of a detail. I don't know how much it will be helpful, but let's see how it is. Now, remember, जो हम लोगों ने पिछली बार इंस्टॉल किया था, that we installed PySpark, we installed it into another notebook. That another notebook is another VM space for me. So when I come to a new book or when I open a new Colab notebook, I will have to install all of these things again. I have to install OpenJDK again. I have to call this Hadoop again. I have to get this unturned and I have to install PySpark again. Every time I start an instance. Now, अगर ये एक बार भी मेरा हो गया, अगर मैं अगली बार इस सेम कोलैब को ओपन करता हूं, I have to do this step again. This does not come default. But once your state or once your collab shuts down, this instance is over. This instance is over. मतलब जो भी तुम लोगों ने install किया है, that will be gone. So make sure that every time you come into the collab to run a PySpark, you're supposed to run this piece of code over and over again. Obviously, third thing, I am trying to set my environmental variables, and similarly, same thing, I am trying to import PySpark init from PySpark SQL import pass session, and this is my Spark SQL object. Import RE. RE stands for your regular expression. What I'm trying to do over here is I'm trying to check if the regular expression is being imported properly. Don't worry about this. We will talk about this later. This might confuse you a bit, but please hang in there. I will tell you what's actually happening. See, as I said, जो NASA का log file है, it is very, very huge. So what they have done is they have compressed 163 MB and 200 MB file into 20 and 35 MB file, 20 and 60 MB file, 16 MB file, something like that. So what I've done is I have stored those files in my Google Drive. Those are so you will understand. Just give me a second. Try. Okay, this is my drive, this is my Colab notebook, and in this Colab notebook, I have uploaded two files. If you see, one is NASA access log August 95.gz, second one is NASA access log July 95.gz. This is July 95 का log file, this is August.
Hello, sir.
Huh?
Sir,
Yes.
sorry to interrupt you. You told that it is uploaded on Google. I there I downloaded the zip file got downloaded, and in that zip file I can see few files, but when I open that file, I can't find the code are showing right now.
No, ma'am. Actually,
So
if you
becomes
see the, just let me tell you. So what actually is there? There is one zip file. Now that file is very huge. These two files are around I don't know how many MBs, 30 to 40 MBs. I'm not wrong. So we have posted two links. There are two links just below that particular where you have downloaded that particular MD folder. You just go on those two links and you will be able to download these two files. I hope that clears your question.
yes, sir. NASA log link is there,
Yeah.
and code given by Professor Abhijeet for day 8 evening session. That link I clicked, and then that zip file got downloaded. Inside
Yeah.
that zip file, I got Boston Housing.csv, NASA.ipynb,
Yeah. Correct. Now that NASA.ipynb is this Colab wala file. Now, what you actually want is this file, right? So what you do is where you have downloaded that link now on Moodle, you have downloaded that zip. Just below that, there are two links posted over there, which will take you to the site from where you're supposed to download these two files.
I can see only 3 links, NASA log links, NASA log.
Yeah, click on that NASA log link, ma'am. Click on that NASA log link and it will get downloaded.
Because no, what you are teaching, we are not understanding it. NASA access discard can't be downloaded securely. Some error it is showing. So,
Abhijeet
sir,
sir,
I would
sorry to interrupt you.
Yeah.
Sir, actually, even I tried to click on those links which you have just mentioned for the NASA's log. Since yesterday I'm trying it, but I'm not able to download that.
sir, what
I'm
we
getting
are
an
asking,
exception.
just copy that link to Google Colab. We will open it in our Google link in our system, and then we will save the copy on the drive. So it will be easy for us to run the code along with you. Otherwise, we are not getting anything just by seeing the code.
All right. I'll just do that. Just give me a sec. Just give me a sec. Maybe I should stop this and where is that link? Oh, one sec. Just stop this for a moment. Yeah, ma'am, I have posted those links. Can you see them in the chats?
Yes, we can see it.
Are they opening now?
Yes, yes, we are
So,
fine.
it will directly start a download. It is a FTP link actually. It will download directly, ma'am. It will not open. It downloads directly. It's a FTP. It's a FTP link. Hello, ma'am.
Yes, sir, it's downloading.
Yeah, it downloads directly because it is an FTP link. It is not an HTTP link. So it downloads directly. Okay. So let me start with my presentation again. All right. These are the chats. Okay, so let me just go back to this. All right. Now pay attention to this. I was on this import blob. Now someone asked me what is blob. Blob is nothing but it is something that will see this particular data is there in my drive. So I'm trying to get that data from my drive, and blob is a particular library which helps me in doing that. So that is what I'm trying to do. I'm using blob to load this data from my Google Drive into my Google Colab. That's it. Now, when you have this, please remember, you have this on left side of your sidebar, you have this files wala icon. You click on that. Now I have already mounted. This is first, second, third. Third one is your drive ka detail. Now remember, this you're supposed to do after you have uploaded these two files somewhere into your drive. You upload these two files into your just minimize this. Now I have already uploaded these two files into my drive somewhere in any folder will do. That is not an issue. Once you have uploaded these two files, go to this Colab folder, click on these files and click on this. Now this is unmount drive because I have already mounted. When you come on this folder, it will be mount drive. Just click on that and your Google Drive will get mounted over here. This is your Google Drive. Go to Google Drive, go to my drive. Go to my drive. In my drive, I have pasted these two. I have put these two files into. I have put these two files in Colab notebook. So I went in Colab. There is this NASA log file 1 and NASA log file 2. So I just copy this path, and after copying this path, I put it. I put it over here. I put it over here. And once I put it now, I want both the files, and these are the only two GZ files which are available in my drive. So that's why I put star.gz. If you want to access only one file, you just put NASA access.log July95.gz. I run this, and both these GZ files comes into this raw underscore data underscore raw underscore data underscore files or raw underscore data underscore files. Okay, proxy. Ma'am, I think there is a problem on your network side because otherwise it gets downloaded easily. It downloads after download you will see. So no ma'am, it should show only two files. After download it shows only two files and both of them are GZ file only. That is NASA access log 95 July 95.gz and August.95.0. It should not show too many files. So maybe there is some proxy server issues because it is FTP. It should get downloaded easily. Now, okay. So I used Glob. Using Glob, I have mounted my drive. After mounting my drive, I run this code. Now remember, you are supposed to run this code after mounting your drive. You cannot run this code without mounting your drive. If you run this code without mounting your drive, this code will fail. This will not run. This will not upload any file because you are taking this file from your G drive. Why I'm taking it from G drive? Why you need this particular G drive, or why are you taking these particular files, or why are we taking these files like this? The reason is these two files are very huge, 20 to 35 MB ka files. Uploading it using that particular method of this, uploading it using this method, this upload file ka method will take too much time. Now this was a CSV of few, not more than 1 or 2. So that why it was very easy. Okay, can you show mounting nodes? Okay, let me show you how to mount it. So I will unmount it for the time being. There is a request that you show mounting, so I will just show it. So okay, now let me go through this step again because there has been a request. I go to my drive. Okay, I go to my drive. Now, please remember my access will be NASA access log underscore August 95. Now this is GZ file only. I have not uncompressed it. The file as it is, I download, I have uploaded it to my G drive. I have uploaded both these files to my G drive, that is August 95 and July 95. Now I want to access these two files in my Colab. Remember, you have to upload them first in your G drive before you start mounting your drive. Once I'm done with uploading these two files, I come to this NASA. I come to files. That is what you see on this left-hand side toolbar. I come to files. I come to these files of the notebook. Now, first, second, third option, you can see this drive ka symbol over here, a folder and drive ka symbol. Once you hover over it, you will see mount a drive. Click on that. It will ask you whether you want to connect to Google Drive. You say yes, I want to connect. The moment you say that, it will start mounting your drive. You see, mounting drive. Now my drive is here. Go to drive. Go to my drive. It might take some time because this has loaded for the first time. So it will take time to upload. Go to Colab notebook. Why? Because my two files are there in Colab notebook. I go over here. Now there are two files. NASA access log and NASA access log August and NASA access log July. I want to call both of them into this raw data file. So what I did is I took you can took their in path, but what I did actually is I took path of this Google Colab, copy path, and I pasted over here. So this is my path till reaching notebook. And then as there are only two GZ files, I just put it like this. So all the GZ file will be called by the blob and they will be put togetherly into raw data files. So that is what I did. That is how I mounted my drive and that is how I got my data from. So this is raw data. Once you run this, you will see that in raw data file, there are these two files. That is NASA access log July 95 and NASA access log July, August 95. So I hope this is clear now. So,
Sir,
yeah.
sir, can you wait for 2 minutes so that he can upload it and so that we'll be in line with you?
Okay. I'll just wait for 2 minutes. You guys upload it. Not an issue.
Sorry that I'm interrupting, but
No,
just
no, no,
2
no. It's
minutes
okay.
wait.
It's okay. No. It's okay. It's okay. Not an issue. Not an issue.
Otherwise, we are lagging and we are not able to understand.
No. Please do it. I'll wait.
Thank you,
I'll
sir.
wait for 2 minutes. You guys upload it. Not to worry. I'll just start in 2 minutes. I hope. I will start at it's 5:57. I will start at 6. So,
Thank you, sir.
okay. Now, if you are done with Dr. Chaitana, let's go. Okay. If you are done already uploading your 2 files into Drive, do one thing. Come to your NASA, whatever NASA wala notebook file is there, and come to this file. Come to this file. This files. Come to this files and click on this mount. Come to this file and come to this files and come to this logo mount and click on it. After you are done clicking, go to Drive, My Drive, and find where you have actually uploaded it. Okay, I hope you understand. You must have uploaded into some folder. Go to that folder and copy the path of that folder. For an example, my 2 files are there in Colab notebook only. I put this .gz file into Colab notebooks. That is Colab notebook. I have 2 files. So I have copied the part of Colab notebook. I have put this till here. It is Colab notebook ka path. And that slash star.gz. Star why? Because I want to take all the gz file. There are only 2. And then .gz because it has the extension gz. So it will differentiate these 2 files from IPNV files. All the other IPNV. Then just run this and it will run. Is there any other question? Anyone else who is not able to do it, who is not able to pull this off? Please let me know. I will just give a few more minutes to do this. It's okay. Take your time. You should not lag me. Anyone else who is having a problem? Please put. Yeah.
Whenever I am trying to mount my drive, it's telling me to run one particular cell, that drive.mount.
It's asking you to do what, ma'am?
It's asking me to run the particular cell, that is drive.mount. So do I need to run that before mounting it?
No, ma'am. I don't think it ever asked. I'm not sure why it is asking you, but you try running that. I hope it will mount, but I have not seen any such kind of issue before. Means asking specifically that we want to mount, then you run something like that. It has not happened before. So you try whatever it's asking you to do and see whether it is mounting.
Okay.
Hello, sir.
Yeah.
Sir, if you copy that URL from this Chrome browser and share it with us, will it work? Because the procedure which you told, take it from Moodle, it is not working, sir.
I'm sorry, Vandana ma'am, your voice is actually.
Hello.
So I'm not able to hear. Yeah.
Hello, am I audible now?
Yeah, you're audible now.
So what I'm telling now, if you copy this Colab URL from this Chrome browser and share it with us, will it work?
No, ma'am, it will not work. It is my personal space. It will not be shared with you like that.
Because in previous sessions, no, the instructor used to share the link with us, and we used to click on that link so that we had the complete code with us. And we used to just click on the cells in order to run it. So there was no lagging as such.
Ma'am, I think you have a IPNG file, and if you put it into that particular thing, I don't know, miss. Let me try.
It's not working. So whenever I download that file, no, it is showing me discard this file. It is not secure.
Okay, let me just see how can I can I do that. One second, just give me a second.
Sir,
But
can I
I think so.
suggest
It is
something?
possible, sir.
Sir, can I suggest something? To
Yeah,
please
please.
share the link of your Colab notebook you are currently working on. The participants will make a copy. They will go to the file
Yes,
menu
yes,
and they
that
will
is
make a
what I'm
copy on
saying.
their drive. So
Okay,
it won't affect your Colab notebook. They will be doing on their copy of the Colab notebook.
All right, I'll do that.
Yes, yes.
Just give me a
This
second.
is what I
Just
am
give me a
trying to
second.
say.
Just give me a second. Okay, I have shared a link. Please make a copy of this notebook. Don't make changes into this notebook itself, because then I won't be able to show you anything. Uh, is it working now? Vandana ma'am, is it working?
Sir, it is asking for access.
I have
Request has
edited
been sent to
access.
you.
Sir, please keep the access open to the one who is having the link, because we are not
One
able
sec.
to access it.
One sec. One sec. Let me change access again. I have changed. Okay. Let me change. Anyone with the link. Okay. I'm sorry, I have not done it. Now try it, ma'am. There it's working. I have changed the access, right?
Yes, sir, it is working.
Yes, sir.
Yeah. Yeah. Okay, ma'am. All right. Okay. No, it's okay, ma'am. It is not. I should have done this before. Okay. Are you guys done? Please let me know. I'll just wait for 2 to 3 minutes more, because we have at 6:10 we will start, because you guys were lagging. So I'll just wait for 2 minutes. Shall I begin with the next thing? Are we all done? Okay, I think most of you are done with this. So I'll start with the next thing. This is where we stop import globe that globe contain drive, my drive, collab notebook. So this is what I use. Globe is something which I use to take my data from my drive from to my raw data file. It is not the only library. You can use anything. It's depends what you're trying to use. It will not make any changes. So someone is executing in my, if I'm not wrong, someone is trying to execute it into my drive only. So this is why I'm not sharing. So please, if you have got the link, please make a copy of it. Don't try to run it into that link only, because it will hamper. See, it will hamper my entire notebook if you try to do it. So I suggest you guys to.
Abhijit sir, sorry to interrupt you. Just you make one copy, a new copy, so that it will not hamper your code.
That's what I'm trying to do.
Save a copy in Drive and use that copy. Yes.
So I have to go from the start. Okay, let's see. Yes, this. Okay. The second one. Where we stop. Now the next thing is I have got the raw files, but now I want to put into a data set or data frame of the kind Spark. So this is the line which will take these raw files of the text format and put it into a data frame. So I put it into data frame and try to print the schema. As it is a text file, a completely unstructured file, there are no rows and columns, and that's why you have value equal to string. which is nullable is equal to true. So that is all the data is perceived as a single string and there is no distinguish between ye kaun sa data hai, wo kaun sa data hai. So there is no columns. It is not structured or a semi-structured data. That's why it is not having columns or feature, whatever you want. Now, I try to find out what is the type of this base diff. As I said, it is PySpark.sql.data frame. It is a type PySpark type of data frame. It is similarly, if you have done this with Panda, it would have showed you as a Panda data frame. Now I want to see what is there here. When I run this, this is what there. Now there is only a single column in base DS known as value, and each individual row is a separate value. This is first value, second value, third value, fourth value, fifth, sixth, seventh, eighth, ninth, and tenth. The thing is now they are only showing 10 values because there are too many data into this particular too many data in this particular log file. Even if you don't put this show and just put, now remember to put truncate is equal to false, because if you don't put truncate is equal to false, by default it is true and it will show you value just till this date wala thing. The gate history will not be there. Let us first understand what is the structure of this. This is your host ID. That is the host which is trying to connect. This is the date and time at which this request came. This is the type of request. Gate, history, Apollo, it was a HTTP1 request. And this is status information. Now, the people who are done with networks, 200 means successful. If you have anything other than 200, that means error or status error have occurred, and each one of the code different thing. Means if it is 404, it is page not found. You must be all knowing what is 404. And this is nothing but the content size. That is whatever was requested or whatever reply was sent to this particular thing had the content size of 6245 bytes. So each row is organized in this same manner. So that's semi-structured data. Each row has a structure, but it is not in terms of columns and features. So now we will start with data wrangling. The very first thing is I just want to take 15 data sets or only 15 samples from this entire data set and run a small amount of data extraction facility where I take this unstructured data and semi-structured data and try to get it into structured form. So I am just taking first 15 entries from this log file and calling it as a sample log. Okay, so what I get is I have taken out of this 3000 or 4000 lines, I'm just getting this. Okay. After running find spark init, ma'am, try to run this file first. This one. If you are not successfully run this file, this will not run. It will not run. Okay. Yeah. Where was I? Sorry. Yeah. So I have taken a smaller set of this entire data set, and then the first thing I want to extract from this data set is host name. Now this is where your regular expression comes into picture. Now please understand, I know that whatever host name is there, it will come in either of these two patterns. This is also host name which is requesting. This is also host name which is requesting a data from me. So the thing is, when I see the pattern, I know that there are two full stops or three full stops. That is, if a host name like this, there are two full stops, a string, one full stop, second string, a full stop, and third string. Or if I talk about IP address, first string, full stop, second string, full stop, third string, full stop, third dot, and then string. So full stop. So it will be one of these either two cases where I'm supposed to get this thing. So what I did is I took a host pattern and I have put it into regular expression. What kind of regular expression is this? It will start with a string. It will have a full stop then. It will start with a string. It will have full stop, second full stop, and then it will have a string and a space. It will terminate at a space. Now you understand this. In this regular expression, I am using two full stops. Why? If I use three full stops, all this thing, unicom.net, burger.later.com, they will not be included in this regular expression if I do that. So what I did instead is I just used two full stops and then I'm scanning till I encounter a space. So when I'm talking about IP address, I will scan this because of this first is. Because of this first is, I will scan this 199. Because of this second, after this first dot, because of this second S, I will scan this 72. And because of this third S will start with from dot and it will go till this space. So from this, it will start from this 81 and include this full stop, include this 55 and go till this space. So this will include all these four values. This is how your regular expressions are. Sorry, I can't go into this because it will take a lot of time. So now when I run this regular expression, I take this re.search, I give this host pattern, I give this item, and I group them as one. Now understand, there are 1, 2, 3 strings. So what I'm done is I'm taking these three strings and grouping them as one element. This 199.17.81.55 is one element. This unicom.net is one element. How to distinguish into three different elements, we will talk it about later. What will happen if I don't put this one? We will talk it after the second or third block. Just wait for it. If research host pattern is item, that is you find a pattern like that, you put it into the list. If you don't find a pattern like that in that row, you just put no none for item in sample log. Now this is your normal Python script. You must understand that you are iterating over this sample log until you completely exhaust this sample. So 15 in sample log, there are 15 entries. So you will have 15 entries in this host file. Similarly, we are doing it for timestamp. Timestamp, now understand, this first string, that's why you used S. Now here you have integers. So that's why integers and doubles. So that's why you are using D, W, D, 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 W because it is July. So it is a word. So D, why it is 2, 3, 4, 5, 6? The reason is there are two integers, there are three strings or three words, there are four integers, there are two integers, so on and so forth, and that's why it is using it. And that's why it is mentioning the number of elements which it is supposed to do. They are actually extracting this URI, this method wala thing. Now you have get, that is whether it is get or post, the URL itself, and what type of protocol is being used. So there are three sections for this particular third thing. First string, second string, third string. Now remember, it is not using group 1 over here. It is not using group 1 over. So what happens is when you run this code, you will see that there are three different elements for each row. The first element comprises of three sub-elements, that is get, history, Apollo, forms one element, but all three of them are different. They are comma separated. Where you see this entry where we have used group 1, all these 4 or 5 things were combined together as a single element. So the 01 July 1995 000001 -0400 is a single element, whereas this get is one element, history is one element, and STDB1 is one element, and combining these three will give us a compound element of one type, second compound element, third, such 15 compound elements which will be there in this particular table. Then I go and extract my status, that is 200, 200, 304, 200, 304, 304, so on and so forth. And at the end, the last thing of this semi-structured file is size. So I have extracted, in this file, I have extracted host, I have extracted date, I have extracted method URL, I have extracted status code, and I have extracted the content size. So I have extracted all those 4 things. Now, this is what I did using our standard libraries, but PySpark gives you something known as regex extract. It is a function which can be used to extract all those values at once. Now, how it works, let us see. We have base FD. In base FD, we have our PySpark data frame. From that data frame, I'm selecting. What I'm selecting? I'm selecting these values. Reg exp underscore extract. I want to extract a regular expression of type. From which column do you want to extract this regular expression? I want to extract it from the column value. You see, all of them belong to column value. The reason is, if you see base FD, if you see base fd.show, there is only one column known as value. All these rows are the part of the value column. And hence, here in the regexp, you're supposed to mention the column from supposed to extract this regular expression. You're supposed to mention pattern over here, but we are not mentioning pattern separately. The reason is this content size pattern I have already declared. This status pattern I have already declared over here. This method URI pattern or method URI pattern I have already declared over here. Then I have already declared TS pattern. I have already declared house pattern. So that's why, or what you can do, you can just copy this entire thing that is from here to here and paste it over here in single or double inverted commas, and even that will do. But as we have already mentioned these variables, we are using them. So host pattern means pattern for host, regular expression for host, extracting host. TS pattern means regular expression to extract timestamp. Method URI patterns means the regular expression to extract method URI. Status pattern and content size pattern. Alias means after extracting this regular expression, whatever value will come, that will go under a particular column named as host. Timestamp will go under a particular column known as timestamp. Now please remember, method URI has a single pattern. It is a single pattern which is used thrice. If you see over here, we are trying to extract the first component, first sub-element, second sub-element, and third sub-element. That is, first sub-element will go to method, second sub-element will go to endpoint, and third sub-element will go to protocol. What do you mean by this? If you say this, each compound element has three subsets. So this is my first sub-element, this is my second sub-element, this is my third sub-element. 1, 2, 3. So when I run this line, where is that? Yeah. When I run this method URI.protocol, that pattern, I'm just talking about this first element. All of this first element should only get extracted. I don't want this Apollo and HTTP import. When I take my second element, when I go for method URI2, I only want this second sub element. I don't want this first. When I am talking about this third element, I'm only talking about this third sub element, that is type of protocol, and I'm giving it an alias name protocol. Regex extract. Now this is 1 because there is only one element in the integer type alias status, and this is your content size pattern. So content size. So using this, if I run this, if you see now my unstructured data, this was my original data. This is base.df.show. So this is my semi-structured data got converted into structured data. I have a column name as host. I have a column name as timestamp. I have a column name as method. I have a column name as endpoint. I have a column name as protocol. I have column name as status, and I have column name as content size. With that said, let us go to the next thing. Now here I am checking whether there is any line in base DF which is completely null. That is, the entire line is not having any data. It is completely null. I am not having such a line where the entire line, that is this entire line, I'm talking about entire line, not single element. This entire line is completely, there is not a single thing where this entire line is completely null. So I know that entire data frame is not a single entire entity. That's what they're trying to say. With that said, Now I'm trying to find out in this thing, I'm trying to find out, now remember, from this point onwards, I will talk in terms of logs DA, this new data frame which I have created after, which is having this kind of table into it. Now I will only work with logdf. Why? Because it is a structured data. So all the rest of the entries will be based on logdf. In logdf, I am trying to check whether the host column has any null values, whether timestamp column has any null values, method has any null values, so on and so forth. So I run this thing. Okay, if your RE is not running, just put import RE before that first hostname run, and it will run. Not an issue. Okay. So now, okay, I will show you. Just put import RE over here, and then run the cell. It will run. Okay. Next slide. Here and here I have two things, that is PySpark SQL function call. There is a function name known as call in this SQL function, and second function is known as sum, which I am calling as, or which I am aliasing as Spark sum. So what I'm doing over here is I'm defining a function known as count null, call nulls. I'm using Spark sum, that is, I will go to a column, I will traverse through the entire column to find the null value, and then I will alias whatever coming here to be the column name, that is whatever will be the column. So this is for a single column. I am trying to calculate, this will calculate the sum of all the null values for a single column. I want to do this for all columns. I want to do this for all columns, and that's what the second expression is. expr is equal to count null for calls in log ds dot column. Log ds में जितने भी columns है 1 2 3 4 5, I will take them one by one, run through this particular function, find out the nulls, and then I will calculate, and then I will get my null values for each and every column. Then I run log that aggregate, that is, I want to show them together. And when I run this particular thing, it will go through the entire data set, finding the null values column wise. Now understand, it is doing this column wise. Okay. Now, what it is showing is, when you talk about host column, there is not a single null value. In timestamp column, there is not a single null value. Method main, there is not a single null value. Endpoint, there is not a single null value. Protocol, there is not a single null value. In status, there is one null value. In content size, there are 33,905 null values. This is what this table trying to say. I have listed column wise how many null values are there in each and every, under each and every column. Under the host column, there is no null value, no null value, no null value, no null value, no null value. Under status, there is one null value, and under content size, there are 33,905 null values. So before we start doing anything with them, we are first supposed to get rid of these null values. What I do is I just create a new data frame from base DA where I filter. Now this means not. not base df value dot r like. That is, I am trying to find out a particular entry where value is status. This is the regular expression for status. If you guys know, this is the regular expression for status where the status is actually not present, where net value for status is not this one. This tilde sign means not, where value for status is not present. How many such entries are there? If I go through individually again, so this is going through the entire column of that status over and over again, and it is just showing me that there is only one such value where you have null value in this status column. Now I want to check what is actually the entire content of that line. Null status.df.show. When I try to show this entire value, that entire single row which is there, as there is only one row, I am trying to show this data frame. And when I see that, I actually come to know that in that data row, there is only Alice AAP written into that line. It is not a host node, it is not a time, it is not a method, it is not a URL, it is not a protocol, it is not a status, it is just some blunt, a garbage value which have been by default by human error or by some other error have been put into that log file. This particular entry makes no sense, it has no meaning. In the next line, what I'm doing is, this is the next status. Now understand, I have that null status.df in which I am actually holding only a single value, which is Alice AAP, and whatever is related to this data frame. Now I am trying to extract its host pattern, TS pattern, method URL, all these kind of things. When I extract all of them and represent them, I come to know that there is no host name, there is no timestamp, there is no method, there is no endpoint, there is no protocol. Status value is set to null, and even content size is null. So that means this is a garbage value. This should not have been there. It is some human error or by some particular error that it has been entered into log file. It shouldn't have been there. It has no meaning whatsoever because it is not having host, it is not having timestamp, it is not having method, endpoint, protocol, anything. So I took this null status.df and extracted all of its value which should be there for a proper log entry, but it is not having none of those entries, and I declare that this is not a proper entry for a log file. It is a mistake. It has a garbage value. So now what I do is I drop that value. Actually, I'm not dropping that value. I'm creating my log df again, ignoring this status dot null. That is, I'm ignoring the value which is having status null, and I'm creating this log file again. I'm counting it again. I'm doing all this stuff again. This is where I'm actually creating my log file again without taking the status is equal to null. And here I just want to show that null has been removed. So that's my log. One second, it will run. It is going through the entire data frame again. So that's why it will take some time. So here, this line is dropping this line alisa.p. This alisa.p is being dropped by this line. And then I'm recalculating this particular thing. I want to recalculate this entire table again of count. So now I have host is equal to 0, timestamp 0. These were already 0. Status has become 0. That means now I have removed the value null from the data set, and hence there is no value in the entire data which is having status as 0. Previously it was 1. But there is one more thing to observe. Remember that the total number of null content size were 33905. Now it has become 33904. Why? Because status is null. If this particular entry had status is null and content is null as well. As this entry is removed, this count was deducted not only from letters but also from contents. So that means now you are only supposed to take care of 33,904 entries from the content size so that we can proceed with actual analysis of data. Now we will talk about this content size. We have to get rid of this 33,904 null entries. So what we do, first of all, We just go through entire database to see whether this particular count is correct. Now remember, I am running this particular thing on base day, and that is why it is again coming out to be 33,090. I take first 10 values and try to represent them from this null entries. When I see this null entries, see this properly. Okay. These are the entries. As I know, this one should represent the content size, but it is dash over here. Content size की जगह पर dash है. In place of content size, there is dash, 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 dash. So that means they have not written anything. If you see this status, none of them is having status as 200. And I hope most of you are few of on the network side. You know that 200 means you have a successful reply. If you get anything other than 200, that means there was an error or it was a status. It was only a status message. So that's why it is not having any content size because it is not sending back any content. So that's why all other numbers, that is 302, 404, 50, all those, that is 404, all of them having content size as 0 or content size as dash because it is not having any. Now there are 33,000 entries. If I remove all these 33,000 entries, it is not good. The reason is all these entries which I'm saying are based on some kind of error. This 404 is an error message. This 302 is some other kind of message which we will not discuss. We are not here for. But I want this data. I don't want to delete this data. If I delete this data, it will affect my analysis. So what I do, I replace this dash with 0. It is since it is not sending any data. Instead of dash, I will set it to 0. It will still give me a correct content size. It will give me a content size 0 because it is not sending it. And this is how I do it. Log.df na fill content size with 0. That is, if there is the value is not available in this particular content size, you fill it with 0. So I filled this particular content size with 0 and then I recalculated the count. It will take some time. Okay, I just hope I complete my data running part. Just 2 minutes and this will. Yeah. See, now I converted all the data sets to be 0. That's why there is no null value, and hence it becomes 0, 0, 0, 0, 0. All now there is no null value in my entire data frame. My entire data frame of logs.df is set to be executed, and that's what I'm going to do. But before I do that, there is one problem which I'm encountering. In this table, this timestamp is 01 July 1995 000 whatever. I don't want this date in this particular format. I want it to be 01 07 1995 so on and so forth. I want to change the format of this particular image in timestamp. The thing is, PySpark allows you to write user-defined functions from PySpark SQL function import UDF. UDF stands for user-defined function. The good thing about this user-defined function is when you write a user-defined function, even that function will be run with the help of Hadoop. That is, unlike Hadoop, will take care of running and distributing the function on MapReduce, and MapReduce will give you back the answer, and that answer will be taken by the PySpark library, and PySpark library will interpret it. This is a very, very powerful function. And the good thing is you just supposed to write a Python function for this. You just write def pass clf time text. All of this is in the text format. Just pass that text and you know this thing. I hope you know this thing already. This is written in whatever format you want, dot format, from text, from which value to which value. Now this is simple Python. This wala part is Python ka part. This is not machine learning or PySpark. Actually, this entire thing is a normal Python definition. अगर मैं तुम लोगों को वो सिर्फ वैल्यू देकर उसे कन्वर्ट करने के लिए डेफिनेट फंक्शन लिखने को बोलता, दिस इज व्हाट यू हैव रिटन इन पाइथन विदाउट यूजिंग एनी एमएल और पाइस्पार्क. पाइस्पार्क और एमएल के बिना भी यू मस्ट हैव रिटन दिस स्टार्टिंग फ्रॉम हियर. So this is just a normal Python function which will become a UDF, that is user defined function under PySpark. PySpark will this normal function, convert it into a PySpark function, put it into MapReduce, run it on the Hadoop, get back the answers, and give it into whatever you want to represent it into the way in which you want to see this. Now, this is only definition of this particular function. I have defined this function, and here UDF pass time, UDF pass CLF, I will run this function. I am running this function. And now let me see how the data looks like. I want the data in this particular format, and I got it. I got year in the starting, then month, then date, and then the entire time that I wanted. So I have reduced time from here, from timestamp looking like this, that is 01 July 1995 whatever. I have converted it from that to this using UDF. UDF stands for user defined function in PySpark. PySpark allows you to write Python functions, and that will be taken up as a UDF, that is user defined function by PySpark, and run over the Hadoop. So this is one of the most important reasons why PySpark does it. It allows you to define user defined functions using simple Python script. Now I'm done with this setting this data. I just want to print the schema. Print the schema of this new log.df.schema. I have host of type string, I have method of type string, I have endpoint of type string, protocol string, status of type integer, contained size of type integer, and time of type timestamp, nullable. All of them are nullable or true, but I have already removed all the null values. We have removed all the null values, and that's why there are no null values. Now this entire data set has become a structured data set. In this data set, there are no null values. I have removed all the null values. Now, let us see what we did. We have a semi-structured data. I converted into a structured data. I removed all the null values which are from all the columns, and then I converted one of the columns because it was not in my desired format. After doing this, I will run this command. Now, what is this command? Please pay attention. Log df. Now I know that whatever I do from this point onwards will be on a single data frame known as log ds.df. So I am trying to cache that entire data frame in my particular main memory, so it will not go back to data center data sets, fetch that memory and do it. This will just make it more quicker. That's it. It will make it more localized and quicker for me. I will have a quicker access to log. Nothing else. If you don't write this line, it will not change. Whatever we did in this entire part is known as data wrangling. That is data analysis. We have taken a semi-structured data, have used a PySpark library, and converted this semi-structured data into a structured data. This is known as data wrangling, where we have brought data into a format in which we want. From this point, now whatever we did in this was using PySpark library. Whatever we do after this, that is data analysis of logs, may or may not use PySpark library depending upon the efficiency or simplicity you want to implement it. For an example, here I am using a default describe function to describe content size. 2 pandas means I am converting this content size ka whatever data frame into panda data frame. Why? Because panda data frames has a better visualization. They visualize data better. See, which is better, to visualize data like this or to visualize data like, let me see. Let it come, let it show. Let it just show. They will understand which one is better. See, when you show data using PySpark or inbuilt PySpark in PySpark or just using by default show, this is how you get to see it. But when you convert it into pandas data frame, you get a different kind of taking two things to traverse that space. Just wait for a minute to do it. I hope you guys have run it at your side and you'll be able to see a bit view of this entire data set. Let us just wait for a few minutes. Is it problem with my? Let me just check. No, it's connected. It's way too. God. That is so slow. Just a minute. Oh, yeah. Once you execute it, you get the representation like this. Now understand, pandas being a very good library or a very good way of putting the data out, it has a better visualization options with it. So this is by default the show which comes with your Colab and inherent library, and this is your describe converted or your content.size.summary which is ported to pandas representation. Will do that. Now remember, we are porting it to represent it in pandas. Pandas we have not imported in this Colab till now. So it will just take this DF and represent it as pandas. It will not be able to do any function of pandas. The reason is we have not imported pandas library. You can do this, or now this will represent count of all the content cells, that is how many content sizes are available in the database, mean of it, standard deviation of it, minimum value. As you know, now this is very evident to you. We have put 0 as the minimum value, content size we have made 0, that's why minimum value is 0. And maximum value out of all the whatever this 3,46,000 or 34,61,612 values is this value. This is the maximum value out of this all of this. This is one way to do this, or you can actually pull this off using PySpark as well. What you do in PySpark, you take this log.ef.aggregate. Aggregate is a function. Now I have taken function, I have imported function as f. Now there are some by default functions which are available in PySpark, which you can use as it is. F.mean. F.mean will calculate the minimum of this particular column. F.max will calculate the minimum of this content size. F.mean will calculate mean of this particular column. std_dev will calculate the standard deviation. Count will calculate the count of this column. Where to find these functions? There is a PySpark website where all these functions are mentioned. There are thousands and thousands of functions which are available inbuilt, which you can use as it is. Now remember, after doing this and putting these alias names, I have ported into it to represent as a pandas representation. So I have given the alias name, minimum content size, max content size. So this is min content size, max content size. So this data is same as this data. Only difference is this is you have got from this describe word itself. That is describe function which is inbuilt in there in Colab. Whereas this one you have derived using function f. Now the question comes, अगर इतने easily हो रहा है तो ये करना ही क्यों? There is one very solid reason. This describe is a linear kind of function. It will not run this entire, it will not take this column and run this through your Google, it will not run it using MapReduce or Hadoop. ये रन करने के लिए MapReduce या Hadoop यूज नहीं होने वाला, जबकि ये रन होने के लिए MapReduce या Hadoop यूज होगा. If you remember, when I run this particular content size describe, it took me a bit of a time, 10 to 15 minutes to execute this and get this value. But when I ran this particular PySpark.sql function.f using this particular thing, it got executed immediately. The reason is this thing is independent of this thing is independent of this thing is independent of this. Calculation is independent of this. So using this f function, I was able to produce MapReduce which ran all these 5 things on a different MapReduce program, got back the answer and gave me the answer. So this was actually faster. If you have noticed me executing it, this was a bit slower and this was a bit faster because I was using Hadoop. It used Hadoop. I was not using it. It inherently used the Hadoop. Now, next, after this, most of the things are your standard analysis thing where most of the thing you might be new, because all of these functions are standard Python functions. There is no something which is very, very relatable or very, very into or which is specific to PySpark. So this is where I want to know total distinct HTTP status codes. Status code means 200, 404, 3000. I'm talking about what is their count. So there are total 8 distinct statuses. Status means 200 might have appeared thousands of times, but I only want to count 200 once. So that is what I'm trying to say. Distinct HTTP request status. Now I want to print count of each and every one of them. When I talk about status 200, there are 31 lakh 00542 entries. When I talk about status 304, these are the numbers. When I talk about status 302, these are the number of entries into my log file, into my data frame. If I talk about 404, these are the number of entries in my data. 403, these are the number of entries in my data. 500, these are the number of entries in my data. So on and so forth. Now I want to plot these values. Now before I plot this value, I hope you guys understand that the highest value is around in 31 lakhs and the lowest value is 50. When you plot this graph, it is gonna look a bit skewed, a bit or a very big skew. This is your 31 lakh and this is where your 15 value 15 is there. Now please understand, because this value is too big, you are not able to see this value at all. And hence what I did, I want all of them to look proportionate. At the same time, I have to make sure that this is visible. These 4 values are visible because they are in 2 digits, whereas all the other values are very, very, very big. So what I do, I take log of this status frequency df.count. f.log is again a function which is there in PySpark. Now, please remember, f is an object created from the PySpark function, and hence whenever you see this f dot, that means it is a PySpark function. And I run this. See, if you see this, it was immediately shown. When I run it using PySpark, the speed is a bit higher as compared to normal speeds. Now, this is what I get when I plot this graph. Now I can have a bit of an understanding. Seeing this graph and making out something is very, very difficult, but seeing this graph is easier. All of them are logarithmic values. Now I go and calculate host sums. What do you mean by host sums? That is number of hosts. Let me just show you. How many number of hosts try to connect it to this particular thing? That's what I'm trying to show. Now, if you see this 8th entry is null. Why it is null? Let us see. So there are 7,660 such connections which came to me which had no host whatsoever. So this might have been malicious or faulty entries or some kind of entries which did not require, or some kind of messages which did not require you to have host. So all of them has this host value as null, and host value as empty. This is empty string. This is not null. This is empty string. So path df, long df, path endpoints. I want to calculate the endpoints. Now this is endpoints. Endpoint means, if you see NASA logo.mail.jf, there is a server where I have posted or I have saved my GIF files. So how many times that particular file got accessed or that endpoint got accessed, that is what we are trying to say over here. So this particular image file got access 208714 times. So that is, there are 2 lakh 8,714 messages which belong to this NASA logo mail.file. There are around 1,64,940 messages meant for this logo, KSC logo small.gi, so on and so forth. So these are endpoints. Endpoint means the actual file which got accessed over that host. In that host, which file got accessed? So this was the file which got accessed. This was the file which got accessed. This was, most of them are logo file. If you see image file, that is comes on NASA ka web page. So files was got extracted most of the time, whereas other files are waiting. Now I want to see the top 10 error endpoints. Error endpoint means I tried to connect to those endpoints, but I got an error when I tried to connect to those. So not 200 means, see, when I have 200, that means I have successfully retrieved the data. The content size is not 0. But here I want to calculate endpoints that is with error. So I can have that it is equivalent to 304, 302, 404, so on and so forth. But instead, the simplest way is it is not 200. When the status of a particular entry is not 200, that means it is an error code. And because it is an error code, I will just put it into error entry. So these are the counts of error. NASA logo small may, whenever someone tried to access NASA logo small, there were 40,082 error due to this. Due to people tried to access this single file. ASC file को access करते वक्त there were 23,763 errors. When I tried to contact Mosaic logo small, there were 15,245 errors. When I tried to, so on and so forth. So they are giving me the number of errors occurred when I tried to access this particular file. This is top 10 of them. Now, this is talking about unique hosts. Okay, 37. So please understand rest of these things. Okay, these are talking about unique hosts. How many unique hosts are there in my particular? And there is a function of PySpark known as day of the month. That is, it will take the day of the month. What do you mean by day of the month? Let me tell you that, and then we will stop. Okay. So this is something which is in chronological order. This is first. That is, if log file starts from 1/7/1995, it will go on recording the first 1/7/1995 ka data. Then it will go to 2737. It is in chronological order. So this 1/07/1995, it will count it as day 1. Then 2/7/1995, it will count it as day 2. 3/7 will be day 3. 4/7 will be day 4. 5/7 will be day 5. So on and so forth. So yeah, you see, day 1 mein how many connections were there? Day 2 mein, day 3 mein, day 4 mein, day 31 mein. So on each day of month, how many connections were there? I can see that. So all of these things are data analysis part. And in this data analysis part, there are some points where you have used PySpark, but the most important part where you have used PySpark is data wrangling. So I hope I should stop. It's 7 already. So if you have, we still have time for a few questions, maybe 4 to 5 minutes. We can go overboard because we wasted some of the time. So please, if there are any, see, next of the thing you just run, it will run. They are just analysis. So there is not too much to tell about. One thing I would like to clear is using only PySpark to train your entire machine learning algorithm is your advice. Try to incorporate 2 to 3 more things, understand your data, and try to understand where you need to use PySpark. For an example, when we talked about this, that is content size, we use describe function. When you use describe function, it took a lot of time. But when I used PySpark function, it went way too quick. So you should be able to understand where I'm supposed to use PySpark or where I'm not supposed to use PySpark. If it is possible to arrive at same output without using PySpark, try avoid using it because it will use Hadoop, it will use MyProduce, it will consume a lot of resources. On top of that, it will not give you performance. So you have to be judiciously understand and analyze your data, or understand your data before trying to use PySpark, have anything or to process that data. Have a better understanding or a correct understanding of your data and try to understand which functions should I try and report to PySpark. Don't just blindly report everything to PySpark. That's what I will suggest. With that, are there any questions? I will stop sharing this and I will start my video.
Participants, if you have any questions, you can ask.
Sir,
Yeah.
you have mentioned that the big data, the size of the data, which can be called as a big data, will be depends on person to person or perspective, right?
Yeah.
But there has to be some kind of a trade-off or a threshold beyond what
Yeah.
the data can be called as a big data.
See, that's what I said. It depends on actually two things. First thing is what hardware you're using. Second thing, what libraries you will be using to process them. Third thing is what type of data. Means if it is semi-structured data, for an example, if it is semi-structured data and you are talking about 1 GB of data, and if you're talking about structured data which is 2 GB, then I can call a semi-structured data of 1 GB to be big data. The reason is I have to do a lot of pre-processing into this. For an example, this Dasaka log file, it has a lot of pre-processing into it which will go into the picture. So even though same, now for an example, in this NASA log file, if I would have been given that table wala data, that is structured data and unstructured data, I had to arrive at the same semi-structured data, I had to do a lot of more processing. A lot of more would have gone into picture. So it it is not a simple answer कि क्या मैं से big data बोल दूं. If that would have been the case, it would have simplified so many things. But the thing is, there is not a clear-cut answer, and that's why you have so many white papers relating to what you are supposed to do in what you're supposed to get in one session, what you call it at large at one side and not call it at large second side. For an example, that's what I said in the beginning. Forget about every other parameter and just let us talk about large the size of the data. 1 GB of data and I have a hardware CPU. If I am having single CPU, I might call 1 GB of data as a big data or a large data. But if I am using GPU, that 1 GB data might not be big data. It has become a smaller data because GPU has a more processing power. When I'm talking about ASIC, it is a very small data if I talk in terms of ASIC because it is particularly programmed to run machine learning algorithm. So it becomes very, very quick to run that particular thing. At that time, I don't want to use Hadoop. So it is very, very subjective in regards to hardware you are using, in regards to machine learning algorithm you are running, and that's why it needs research. So that you can show the trade-off points. If this is this kind of semi-structured data, this is what you do. If this is this kind of unstructured data, this is what you call it big data, and you should run Hadoop. That is why design changes around machine learning algorithm based on this particular fundamental. Yeah, I agree. Now, that this thing is very difficult to understand in one practice session. I agree to whatever you said, but I only have one session. What can I do? You don't have to, Mahesh sir. Mahesh, ma'am. Sorry, I don't. You don't have to differentiate between them. The thing is, PySpark itself will take your data. See, for an example, what does Pig do? Pig takes a task and posts it over the Hadoop. So you don't worry about Hadoop when we talk about Pig skill. Similarly, when you talk about PySpark, you don't have to worry about Hadoop. The Hadoop will be taken care by PySpark. PySpark will individually take care of Hadoop. You don't have to worry about it. It will take your data, it will take your queries, it will distribute it over MapReduce program, and it will give you back your answer in the PySpark using PySpark library only. So you don't have to worry about how many Hadoop or how many MapReduce it is running. But the problem is it will try to run each and every function over the Hadoop. And if your data is not large enough, it will give you a bad performance. That's the problem with PySpark. Ma'am. Okay, shall we stop then? It's in between due to that link. I wasted a bit of a time. Sorry for that. So, are we good? Harshil sir?
Yeah. Yes. Yes.
So, should we stop
Okay.
now?
Yeah.
Okay.
Sony ma'am, please present your screen.
Ma'am, one sec. There is one thing. One question
Yeah.
which I Harshil sir,
Yeah.
one
Yeah.
sec.
Yes. Yes.
Nirbhay Chobe sir, sir, one sec. Let me clear it out. Is there any difference between unstructured and raw data? Unstructured and raw data, sir, actually depends in what context you're talking. Raw data can be anything. It can be bytecode. It can be even a bytecode. I can call it as a raw data. But when I talk about unstructured data, I'm mostly talking about reviews which comes from Amazon or tweets or something which is words which but it doesn't have any structure as such. So raw data can be byte, bits, anything. When I structured data, it has to be particularly. Mostly, I'm talking about characters in that specific context. Okay, Harshil, sir, continue.
Yeah. Thank you, sir, for taking out time from your busy schedule and teaching us hands-on PySpark in Google Colab. Thank you once again for your excellent session. Please accept the virtual memento. Thank you.
Thank you, Harshil, sir. Thank you, Rathod, sir. Thank you, all the people who are involved in this particular FDP. I hope I try to make sure that you guys understand as much as I can, but I don't know how much you got it, but still try to run that script. You will understand it better. It is there. It will run. It is all of the requirements are there, so you will not have any issue. Thank you, Harshil sir. Thank you, Rathod sir, Soni ma'am, Renuka ma'am. Thank you for this beautiful opportunity.
Abhijeet, thank you very much. Thanks a lot. Just for the information of the participants that Abhijeet is doing the PhD at IIT Bombay, and he has come out of the COVID-19 also. He was positive and he has fighted a COVID-19, and after that he is delivering a session. So hats off to you, Abhijeet. You have given your 100%, and after so many challenges, you overcome it and you delivered a session for 2 hours. That's a great thing. Okay.
Thank you, sir.
So thanks Abhijeet. Thank you very much. Thanks a lot.
Thank you, everyone.
Yeah.
Thank you for listening to me so patiently. Thanks a lot, sir.
Okay. So participants will meet tomorrow morning. Okay.
राठौड़ सर.
हाँ मैडम कौन है? Yes.
अपेक्षा मैडम बोलती है.
अपर्णा मैडम. हाँ ओके.
नहीं,
जस्ट अ मिनिट.
अपेक्षा मैडम बोलती है.
अपेक्षा मैडम जस्ट अ मिनिट. ओके.
सर उद्या 3 to 5 एक्स्ट्रा सेशन असणार आहे का?
मला आवाज आलेला नाही मॅडम. आय कुड नॉट हिअर यू क्लिअरली.